Get recording. Hello, welcome everybody to the weekly study group. And today I'm super excited to present some new upgrade. I think ScriptTS that's going to make your life both for deployment and when you interact with the contract much easier, I hope. So yeah, feel free to interrupt me anytime you have a question because this is a pretty significant upgrade. So you may probably very different from what you have been using it previously. Okay. So, in one of the first videos we did, I showed you how to, test the smart contract and also how to deploy it. After you deploy it, how to interact with it by calling its public methods. And today, I'm going to show you, update it. By the way, can you guys see my screen or
Yes, we can.
the browser?
Yeah.
Okay, nice. Okay, that's good. Let's make sure it's good. So if you remember then, it's kind of, it's because of the TypeScript, the contract part is pretty good. But then when you are writing the off-chain code, you can do it, but it's a little bit of complicated especially for newcomers here. So that's why we decided to, I'm here. We want to make it much simpler. So here, that's why we have a few abstractions from now. One is so-called a provider. Okay, this is a abstraction. You can almost think about, is this abstract entity that provides, connection to the Bitcoin network. Okay, for example, when you want to broadcast a transaction, that's how you do it, right? So instead of calling some minor API using HTTP, and then it's all wrapped under the hood. So for you only see like a provider, and then you can just say, when you're ready to send, you just call this provider, and this provider is going to be bounded to a contract. Okay, so give a few examples, right? For example, you guys from Tao, so you probably know, internally we use one of the APIs is from What's on Chain. Okay, so What's on Chain you can think about is a provider, right? Because you have some mining nodes that's connect to the other miners. So and also you offer APIs, so other people can query or use it to broadcast transactions to the network. Okay, so we make a wrapper on top of this, pretty much. So you can say, oh, internally we have a What's on Chain provider, we have a Gorilla provider, we have Sensely provider. It doesn't matter. For users, they mostly have using these two instance of this, almost abstract class. Okay, one is called first we're going to show dummy provider. So this is the provider you probably want to use when you are just doing testing. Okay, local testing, because remember, for us, the good thing about Bitcoin contract is you don't have to send it to the network you don't need to run a node or connect to a node to actually verify it, because everything is functional. Basically, it's a pure function, so you can always verify it locally without any network or even running a local node. So this is the provider you want to use. It basically means it's a local provider. It's like a mockup provider. And when you ask it to send transaction, it actually does nothing because it's not connected to the network. Okay. So another one you want to use just called default provider. Basically, if you're not doing something very customized, you can almost always use this default provider. Under the hood is boundaries of many different APIs together, but that's a detail for users. You don't have to do it. Okay, so it's also very easy to get these two providers. You can just do it. For example, we have a dummy provider. You just do it. That's it. You don't have to give it anything. And if you want to use a default provider, you can always give, whether it's specified is a mainnet or testnet. That's it. Okay, any question about the provider concept so far? This is new. So feel free if you have any questions. Okay. If not, let's go to another concept called signer. So signer, you can almost think about, previously when you are doing the local testing or when you deploy, you always have to, you always have to hard code your private key, right? Imagine, if you are a real application, when you're using the contract deploying chain, want to deploy it and then integrate, it's kind of risky, right? If you just put your raw private key over there, it's just not usually how a real application works. So that's why we have this abstraction. It's almost like an abstraction represent some private keys. Okay, so why do you need this private key? Because as I said, a provider, you can use the provider read and also to write to read from the blockchain, and also let's say which block it is being mined and what the mempool looks like right now. But when you write to it by broadcast transaction, most often you need some authorization from the users, right? The users have to sign a transaction before it becomes valid, and then it can be accepted by the provider. Okay, so this is the abstraction of, you can almost think about it as a collection of private keys, but you wrap it around in this class. Okay, so a simple example would be like previously we pretty much just give a single private key and you hard code it. That's the simplest type of signer, but it can be also complex. When we talk about how to integrate with other existing a wallet, you can also think about as a signer. So the basically is, as the name suggests, it just signs a transaction before you broadcast it. Okay. Is this okay? Concept okay? Signer? Okay. So let's say, here we want to first show you how to test a contract using the new, abstractions. Okay. Previously, as I said, you have to hardcode the private key. You have to construct the manually the transaction, and then call like a third-party API to broadcast it. Okay. I mean, it's doable, but it's not easy, as I said. Hopefully, after I walk you through this example, you'll find that why we have to do this big upgrade is much, much simpler. It just, most time it's just a couple lines, and then everything is handled. Okay. So let's say, as I just said, this is just for local testing. So a lot of times you can almost always need only create one signer. This one signer is like a mock wallet. So this wallet can be, initialized like this, right? So basically, you have to tell him only two things. One is the private key, this wallet contains, and also you also connect to a provider, okay? Because for wallet, you can almost think about it's only manage your private key, but it doesn't have the connection to the network. So by this way, this signer not only has the private keys, but also is now you can think about it's almost like a wallet, right? It's also connected to the mining network, okay? So in this case, this test wallet, this object signer is both a signer because it has a private key, but also is a provider because the provider is one of its property internally, okay? So once we have the signer, what do we do? Now this is how you create a signer, right? As I just showed you, because it's testing, you can just say, hey, use a dummy provider. And then once you have a private key you can use for this testing, you can create the signer like this. Okay. So now we have the signer and the provider. So how do we, bind it to our specific smart contract, right? Because if you remember our contract, every contract is a class, right? And then once you initialize it, it becomes an instance of that class, right? This is a smart contract instance. So you can, every smart contract instance, you can always, say connect to a signer. And then when you call some method, if you need some signature, it will automatically sign. And when you are ready to broadcast, you will also, send it to the network. You don't have to know, you don't have to manually sign it by calling sign transaction or sign message as before, or you don't have to say call some API to let's say some, what's on chain API explicitly to broadcast. Everything is handled under the hood. So you don't have to know any of the details. Okay. So let's look at the one example here. For example, I have this contract called my contract, and it has this, public method called foo takes 2 arguments. Okay. So now it's very easy. How do you do it? Okay. So again, you can, this is the same as before. You can initialize it to create a new instance. And once you have the instance, right, as I said before, you can connect it with the signer. Okay. So once you have this, how do you call it? You just call, okay, the same name and give it the same arguments here. But note the difference. Can you note the difference with before? Anybody who has tried this before? Can you know some big difference? Give a hint. There's two major changes here. Can anybody note the difference with the new syntax? This is how we call it today. Domingo, you want to have a try?
I'm not that familiar with that. Initially, I thought about the methods. I mean, here we provide the parameters, but these options, I don't know. Maybe
Yes.
those options
Yes,
are
that's a big difference.
To specify the provider and the private key and so on.
Mm-hmm. Okay, good observation. So, okay, I don't want to, give you guys guess time anymore. So, you go. The answer is 2 difference. One is, as you mentioned, the options, which I will cover later. Okay, very soon. Okay. So another difference is you should notice here. So before, previously, we just called instance.foo, right, by calling this function. And then because we are changing this the signature of the function, basically we add a new parameter here. So that's why we cannot just call .foo, because .foo only take 2 parameters, right? Here, that's 3. So for every function foo is now coming, that's another equivalent function under the dot methods property. Okay, so you don't call it instance.foo anymore. You call it instance.methods.foo. And this function has the same, signature as this one, but the only difference is that it adds a new parameter at the end. Okay, so this function this parameter at the end is just an option. It's a class. This is an interface called method options. So it gives us a bunch of the configs that you may have to manually specify, but you may not. If you are like using, a lot of time the default works out of box, but I'm going to explain in which case you want to customize it. Okay, so just to highlight what's the major difference as before. So one, you have to call this, instead of instance.foo, you call instance.methods.foo. And then also that's the option at the end. Okay, let's look at this. Look at one example, right? Okay. So here, let's say, again, we have the demo. It's one of the simplest contract, if you still remember. So basically it has 2 numbers, you can add them, and then you can also subtract them. Okay. So as before, always you have to do it. First step, you always compile, and then second, that's the difference here is, again, you have to give it a provider and also the signer for it. Okay. So after that, this is the same way you initialize to be an instance, and then here's the difference, right? You connect it with the signer. You're binding, you specify the signer for this contract. Okay, in case it needs to sign or broadcast. Okay, so if you remember, the demo has an add method before, so that's how you call it, right? So you just say demo.methods. You have a methods function here, right? Property. and then you got that add, and then you give the same arguments before, and then you also have this option you have to provide. Okay, for in this case, it's a bunch of properties. Most often, you don't have to specify everything. So you only, in this case, you only have to, for us, we only have to tell him what's the input UTXOs that's being spent. So because in this case, it's only local testing, so we can just give it some dummy value. Okay. So what does this function returns? It returns two things. One is the full transaction that's going to call this method. You can recall it. We name it call transaction, and also it's going to tell you, because each transaction can have multiple inputs, right? Each input can call a contract, right? Basically calling unlock some locking script in previous UTXOs. So this pretty much give you, which contract, which transaction is calling this method, and also in which output. What's the index of the output? Okay. So if it's live network, this will just already broadcast the transaction. It's out there. Okay. Because this is testing, so we want to make sure, once we have the transaction, and also we want how to verify it. So if you still remember the previously, we called the verify function, right? And then give it a callback. And in this callback, we call the, demo.add, but not anymore. So this is the new approach. We want to do local testing. So basically you call, on this transaction, you call verify script. So basically you verify the contract, right? Verify the Bitcoin script by saying whether it returns true or not. Okay. And this is the contract we are calling, right? Because for each transaction, you can have multiple inputs, and this is the input we are concerned, right? So again, return the result, and then it's the same with before again. Okay. Is this example easier to understand than before? Comments, please. Is this easier than before or more complicated, you think?
It looks, I'm not that familiar, but it looks easier. It looks like a bit of syntactic sugar, right? So let's go to write. Probably easier to understand. It might be a little bit maybe confusing to provide the provider and the private key. So having those two together can be maybe confusing, but for coding wise, it looks much simpler. That would be
Okay.
my take.
Okay, great. I think here, because we are doing local testing, so you may not always see the benefit of provide this. It's not like a clear cutoff. Say, the provider and sign is much easier. But when I show you some, when you deploy it, especially when you connect to a wallet, it's like at least in my mind, it's like 10 times easier. The code wise, and not only the line of code, but also the format of code is also more intuitive, I would say. Okay, great comment. Yeah, you can almost go back to your old code and then compare with this. So yeah, this is a simple example. So it's not too. I would say the benefit is not too great, but the big benefit is coming if you have, let's say, go to the next when you deploy and call a contract. Because here, right, this is, as I said, dummy. Because this one is not doing anything, actually broadcast. It's just when you ask it to broadcast, it just do nothing, right? It's the no op because it's not connected to any real networking node. Okay. Any other comments before I go to the more complicated examples? Okay, let's keep going. So I just show you, right, how to use a signer and provider and then connect it to a contract instance for local testing. But what about, when you are deploying to a live network, either testnet or the mainnet, right? And then the good news, the code looks almost exactly the same. You just you pretty much swap out the signer and provider. So I will show you how it looks, and then you are the judge to tell me whether you can tell much difference when you are doing local testing and deploy. Previously, these two are very different. You pretty much have to do totally different things. For example, in the local testing, you have to call this verify on the instance and give a callback. In the callback, you call the contract method, and then if you are like deploying, you have to call the API, the minor API to broadcast it. For here, we are almost unified these two. You can almost tell no difference other than the signer and provider. Okay, let's keep going. So for example, here, I want to have as I said, we have most of the time, you only need two types of providers. The dummy provider used for testing, and then another one called default provider. If you want to broadcast to either the test net or the mainnet, right? Depending on when you give it the constructor parameter, you can test it to use testnet or mainnet. Yeah. And once you have this, we also have a few signers, but in this case, you can have a Watson chain or you have a Sensely. For here, we just give you an example, right? You can also have Watson chains. This is a provider, and this is the signer. So here, because a lot of time we use the Sensely, we use the Sensely. Here, this is the wallet. So by default, we have a signer called Sensely signer. Okay, so this is almost for people who are not familiar. This is like a MetaMask type kind of a crypto wallet. It has a Chrome plugin you can always install, just Sensely. So once you have the signer as before, the same as before, you connect it with the instance. Okay. Okay. So here, this is the amazing part. I think this will show you why we have this abstraction. Again, so you can do an instance, you connect it with the signer. If you remember how we deployed before, you pretty much have to manually create a transaction. You get some inputs to cover the fees, and also you have to have some initial deposit, also cover some initial balance into the smart contract, and then specify which output contains a contract, which have the change, right? And then after you construct the transaction, you have to manually sign it and then manually broadcast it. Okay, it's a lot of code, and it's pretty like a boilerplate, right? Because every contract is deployed almost the same way. Instead of now, look at this. Only one line, right? Just one line. Everything is gone. Everything is done. You see the difference here? Once you're connected, you just call deploy and then tell, oh, what's the initial balance in this contract UTXO? It just literally just one line. Everything is ready. It's already. So basically, this create the transaction and broadcast it. Okay? Much better, I hope. Just one line here. Every contract, you can, if you want to deploy, just call deploy. That's it.
Yeah, definitely.
Yeah. I don't know. Yeah. Yeah, you can always, if you are not impressed by this, you can always go back to your old code and look at it and then compare. You will feel, you'll find it much elegant right now. Much, yeah. I can almost say you cannot be even simpler than this because it's just one line. Okay. So what does it under the hood, as I explained, right? That's the old way. You create the transaction, you get the inputs, you get the outputs, specify output, and then you sign the input, and then you find some endpoint to broadcast it. Right now, everything is wrapped under the hood. You just call deploy. It's gone. It's done. Everything is done. Okay. All right. So this is the deployment, and also let's look at how do you call it. Okay. So if you still remember, when you're doing local test, we again do the same thing here. The instance, we have the methods, and then we call the function we want to call originally. Give it the parameters. The only difference we also give it some options. Okay. So once this finished, It's already called. The transaction has already been, constructed and then broadcasted. So also, it's literally just one line to call it. So again, previously, right, you have to find where the contract UTXO is, put in the input, and create a new outputs, and maybe it's stateful. You have to propagate it, and then you have to manually sign and then broadcast it through some endpoint. Okay. So again, here again, if it's a simple case, it's just literally just one line, like a deploy. Call is just one line again. This also has already finished broadcasting the transaction, and then give you back the transaction ID if you want to view it. Okay.
How does it know where the contract is, though?
I said again.
How does it know where the contract is? The
this is the instance.
So it's only
okay.
Okay.
This is the instance.
Okay. So you've created it previously, so it remembers. But if this was a contract that you hadn't called before,
yes. So for that is very good question. So here, because this is a simple example, you are pretty much doing in the same process, right? So you create it first, and then you deploy, and then you call it. But if you're not, let's say somebody else deploy it, and then you want to call it, right? And then we have something coming, which I think I'll probably cover next time. Basically, you just tell then you have to reconstruct the instance, right? So you need the contract, the class, and the out point, yes.
Yeah.
And then under the hood, we're going to use watch-on chain to fetch back and then parse it back to create an object, the instance for you. That's another type of workflow. Great point. But if you are just playing with it, right, after deploy, you have the same instance. It's still in your memory. It's still in the code. This is the same piece of code. So agreed. Your approach is more realistic. But here we want to just have the simple example, showing how to deploy it and how to call it. Okay. Yeah. Great point. Okay. So both here, deploy and call is just literally just one line of code. Okay. No more tens or even 20 lines, or even sometimes hundreds of lines of code. It's just deploy, then call it. That's it. Okay. So let's look at some, because here we have the options, right? So I have to explain, most time you pretty much only have to follow our example by providing a few options, but sometimes it can be much more complicated. Let's look at one use case. A lot of times, right, when you are trying to call some method, you have to give it some signature, right, because you want to authorize it. Not everybody can call this contract, right? For example, you have a so-called pay to public key contract, and you want to have the person who can knows the corresponding private key to your address. That person can provide the legit signature, right? So the problem is, okay, so now you are telling me you don't have to manually sign to get the signature, because just a brief reminder, previously you have to construct an unsigned transaction, and then you have to give it the private key. So once you have these two, you can generate the signature, and then you plug in here, right? But this is a little bit convoluted because you have to construct the unsigned transaction and then manually call the signed transaction and give it the private key. Also, a lot of times you don't want to give out the private key, right? Because if you're dealing with the real wallet, you may not know the contract. You may not know the private key. Okay. So what do we do? How do we call this method here? So this is one example, the options coming into play. So before I've showed you, we have the from UTXO field. So basically, this is the additional added option, right? Parameter. So it's always of this type, method call options. So here, if your contract call ever needs a signature, so you have to specify here. There's a parameter here for you to, you say, which public key is this signature for? Okay, or sometimes it can be address, just public key hash. So here you can specify which of the keys, public keys or address. It can be a single one. It can also be a list. Okay, so here, because we only have one single signature, so we only have to determine, oh, please, signer. Because here, this contract instance is already connected to signer, right? So internally, basically, it has the private key or the wallet, so you can give you the signature back. Okay, but here you have to tell the contract and internally the signer which one do I have to sign, because you may not always want to sign, or you may have multiple pair of keys. You have to tell me, oh, which one I want to sign for this contract to work. So here I just say, oh, this I want to sign for this public key. So once you have this, instead of here manually, because if you look at here, this signature, previously you have to manually construct it, right? As I said, create in 2 steps. First, create the unsigned transaction, and then sign it using the private key. But here you only got a callback here. So this already has the signature responses. So the only thing you have to do is, in place of, if it's a signature, you always use a callback. And then in the callback, because here you have requested which keys to sign, so you get the signature as a response. So in the signature, you just have to find, which of the signature is a list. Basically, it's a list. In this list, every entry is a public key and its corresponding signature. So you call this, built-in function will provide, I find in this list of the signatures responses, I find, the one corresponding to this public key. Okay. Make sense here? It's a little bit different from the previous workflow. So the difference is you don't have to manually sign and construct the unsigned transaction. Is this clear? It's a different workflow. Okay. Domingo, you want to?
No. I cannot unfortunately else. Yeah, it's good.
Okay. So if you forget what I just always said, just one message. So so it's actually simple. You can ask me why if you want, but anytime you need a signature, when you're calling a method, you specify first, in the options parameter, you specify which public key or address to sign. So once you have this, you got a callback. So wherever you need a signature, you actually provide a callback. In the callback, this is all the signature you have requested from here. And then out of all these signatures, you just find the one you need to plug in here. Most of the time, you only need one, signature, right? But, we just provide the API to cover generic case where you may have several signatures. For example, you may have a, multi-sig, right? So you have more than one signature. So in this case, you just find, plug in the signature for different public keys. You can request a list here, and then you can get also multiple signatures here. Okay. So this is one thing that's a little bit of a special case. I wouldn't say special. You have to pay attention. This is a new way to get a signature. Okay. All right. So this is, I think you can pretty much read the documentation if you want to follow it. Pretty much that's what I just told you. Okay. So let's look at the full example here. Okay. So again, it's still the pay to public key contract we just show here. Pretty much you just give address. Then when you unlock, right, you need to give it the private key. Private key hash is good, matches the private address, and then also the signature checks out. Okay. So let's look at the full example. Now, how do we deploy it? Okay. So this is not only deploy it, but also cause to unlock it. Okay. So now hopefully you can see. Okay, so the full picture here is not only deployed but also called. Okay, it's a little bit. I think maybe like 20 lines of code or even less. You do everything here already. Okay. First of all, here we just have we use like a test wallet because we're not trying to in production. So you pretty much just have the private key, and also we have, if it's not testing, you can almost be sure you always use a default provider. Okay, you can give it the default provider, and then you create it again. This is the same before. You create a new instance. Again, you connect it with the signer. So once you have this one line called deploy, oh, the new contract has one Satoshi in it. I just put one here. It only takes one parameter. Okay, so this now deploy. Once you deploy, how do you call it? Again, I just showed you, right? You methods dot the same name function, because here it's called unlock, it's unlock. So it takes the same, you take a signature, public key, and additional option, because the first argument is signature, so you have to say, oh, which public key I want to sign. So once you configure this option, you will give a callback, a list of signatures, and then you just use you almost always write it like this. You almost always. So you find which one you want, and then that's it. It's already called. So you can always print out the transaction ID. That's it. You just run it. Everything you have deployed and then call it. Okay, much easier.
Yeah.
Yeah.
That's good.
Yeah.
Well, question. So we saw before this example with Select wallet. So just imagine I create my own wallet. I'm interested in you guys adding the implementation for my wallet. And how can we do it?
Oh, basically, this is a common interface, right? So this is almost like like a protocol, right? Wallet is like any other TypeScript or even object already. You have an interface, you have a specific interface. It has a bunch of methods you have to implement. Once you implement, you can also submit a PR, and then people can use your wallet as well. Make sense?
Cool. Yeah.
Yes. It's a virtual interface. Yeah. Once your class implement this, everybody can use it. Okay.
Cool. Thanks.
Mm-hmm. Yeah. Look forward to you have your PR if you have any PR. Yeah. So we have a test wallet, but also have the sensitive wallet. But if you have a tile wallet, right? You guys have a tile wallet. You want to get this working. Yeah, I'm going to actually email back, or you can ask in our Slack. I will send you the specific interface you have to implement, and then people can use your wallet as well. Okay. So this is the benefit of abstraction, right? Because you're not binded to one specific thing. If you want to use the default one, use it. If not, you can always swap it out easily. Okay.
Great, thanks.
Okay, so thank you. So if you look at this, right, if it's you can think if it's a signer, you almost have to take this to parameter, right? One private key, and the other one is a default provider. So if you look at the sensitive here, the difference is it doesn't, because it's a real wallet, so it doesn't expose the private key to you. So you only have to know what's the provider. So that's the difference. But yeah, I can send you the detailed link in the GitHub if you want to extend this signer to have it, let's say, tile wallet as a signer. That's also doable. Okay. And then people can connect to you. So
please do. Yeah.
Okay. Will do. All right. Any other questions? If not, let's go to the final. Go ahead. Anything? Okay, let's go to the final part. So I just showed you, right? How do you using the new abstraction, including signer, providers, and then the simple case when you want to deploy and call. Okay, I just show you. You don't see any code that's manually building a transaction, right? Either deployment or when you're calling transaction, right? So, but what if sometimes you want to customize it, right, for whatever purpose, right? So the reason you don't have to manually construct it so far is because we have a default way to build these transactions, and it works, I think, a lot of times, right? So for example, deployment transaction, what it actually does is you get several inputs. They all the format from a pay-to-public key hash type of a funding transaction from your wallet, from your signer, okay? And then you have a bunch of outputs. The first output is the one that contains your contract. And you may have another one optional if you have extra change, okay? So this is the default deployment transaction format, okay? So I think this is very typical, but just in case, this is the default one. You don't have to, if your transaction, when you deploy, follow into this category, then you don't have to do anything, okay? This is the format. I think in most of cases, it's good enough, right? But maybe there's some other cases, let's say you want to put the change at the first, and then you put the output at the second output for whatever reason, right? Because you may easier to index, whatever reason, we don't know, right? So in this case, you can, this is the default builder. We call it transaction builder. But if you want to customize it, let's say, this is the default deployment, but this one is also the default when you want to call a contract, right? So it has this format, the following format. Okay, for the inputs, the first input is always the one that spent the contract UTXO, and then you have 0 or more to cover the transaction fees, right? Because sometimes you have 0 because you want to use the balance in the contract details to pay for the fees, so you have 0. But if not, you may need extra, inputs to cover the fees, okay? And then the output, what's the output? Okay, so by default, you just have the change. The change goes back to the signer address. Or if it's a stateful, as we talk about, it contains a new state, okay? So this is if you are not doing anything specific, this is the default way we are calling the contract UTXO, okay? But what if sometimes you want to customize it, because, for example, I just give you some hypothetical, right? You want to, hey, I want to change about to the first, or I want to have the second input to call the UTXO, and the first one to be my, fee UTXO. What if that's the case? Okay, for whatever reason, this is one example, but you may have, because in reality, right, people have all kinds of ways to how they want to customize the builder, the transaction, right? Either deploy or call. But for us, we just have the default, which we think is set by a lot of cases. But as again, you may not always be the case. The users have this specific format, right? So in that case, what do? You have to, before you call any of the deploy or calling transaction, you have to bind it with the transaction, so-called transaction builder. Okay, so this builder is a default. Default is using these two formats. If it's good for you, you don't have to bind this transaction builder. But what if it's not? You want to customize it. What do? So you pretty much just call on your contract, you call bind transaction builder. And then for each public method, right? For each method you want to call, this is how you do it, right? So you say, oh, I'm calling the unlock method. And this is again, the options and arguments you want to have. And then you're going to return what is returned here? Pretty much, you can almost think about the unsigned version. How do you want the unsigned transaction look like? Okay, so for example, here, I want to have add one input. I want to add a few pay to public key inputs, and then I want to add another pay to public key hash output, and then finally the change output, right? So this format is a little bit different, right? Because for us here, we only have one by default if it's not stateful, right? Because for our case, it's not stateful, so don't worry about this. So output, there's only one output containing all the changes. But for whatever reason here, if you want to have two outputs, pay to public hash outputs, one goes to a specific address, the other goes to the change address. So you can customize it. This is unlock function. You want to customize it. So you build your own transaction format here, and then you return it. So when we call the method by instance.methods.unlock, it will just create the transaction using this format. Okay. Make sense? Here?
Yeah.
Okay. Yeah. So yeah, that's wraps up about today. I think it's probably a lot of content you guys have to digest. But just quick recap. So basically, we provide a new way, different abstractions. Most importantly, 4 ways. One is the concept called a provider. Basically means you can think about it as like provide the access to the blockchain. Mostly you use it to broadcast transaction. And the signer is abstraction of a private key or a wallet. Okay. Once you have this tool, you can connect it to an instance, a contract instance. So when you want to deploy it, you can just call it .deploy. Then you want to call it just instance.methods.full and give it the parameters. And then you have a bunch of options. And the options, if it has, let's say, signatures, you don't have to manually sign it. You can use our callback to easily get it. And then last, this we assume you have the transactions conform to these 2 type of formats, right? If not, you can always customize your transactions using this bind transaction builder on your specific method. Okay, hopefully this greatly simplified the way you deploy and call any contract. And any final remarks?
Nothing here. Thank you very much.
Yeah, it looks much easier.
Okay. Yes, much easier. Okay. Yeah. Okay, great guys, and have the rest of the day, and hopefully see you all next week. Bye-bye.
Yeah, thanks.
Thank you.
Have a good one.
Thank you.
Bye.
Thank you. Good night.
Bye.
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 Night.
Bye.